think it's working now. There we go. Alright, so this is the review for the honors, section 8. And my paper looks different than yours only because I printed yours 2 pages per sheet to save paper because it was 4 pages otherwise. Alright, so I'm going to do several of these with you. And then what we don't do, the rest will have to do on your own. Alright, so look at number 1. We're taking the fourth root of 567. And I don't believe 567 is a perfect fourth, but I can check in my calculator. And it's a decimal, so it's not. Alright? So I'm going to do my little factor tree. And it's not even, so I know it's not divisible by 2. Let me try to see if it's divisible by 3. It is. And remember, I always underline my prime numbers. And 189, let's see if that's divisible by 3. So 3 times 63. And 63 divided by 3 is 21. 21 is 3 times 7, and 7's prime. So I have 1, 2, 3, 4 3s, and a 7. Just make sure, double check your roots to make sure you didn't forget anything. That all multiplies to give me 567, so I'm good. So if I want the perfect fourth root, I need 4 identical factors. Okay, so I have 4. So 3 raised to the 4th power is 81. 81 times 7 is 567. So I am going to substitute 81 times 7 for 567. And then is x a perfect fourth? No. Can I break it into factors where it may contain a perfect fourth? No, it's just one of them, right? You can't add more x's to it. There's just one x. So x is not a perfect fourth. We can't rewrite it, so that will just be something that stays under the radical. All right, so if we can take the fourth root, we do, and we put that outside of the radical. What is the fourth root of 81? 3, so I'm going to put that on the outside. Can I take the fourth root of 7? No, it's a prime number. It's only factors are 1 and itself, so it can't do that, so it will stay. And we already said that x will stay as well. Everybody cool with that? All right, let's look at number 3. Now, number 3 has a coefficient on the outside already. So anything that I take the cubed root of, I will have to multiply by the -2 that's already on the outside. So is 64 a perfect cube? Yes, its cubed root is 4. Okay, so I don't need to rewrite that into factors. Is m to the 6th a perfect cube? Yes. If my exponent is a multiple of the index, then it's a perfect cube, or whatever it is that we're looking at the time. So I don't need to rewrite anything. Everything in the radicand is a perfect cube, so I'm not going to have a radical in my answer, right? Okay, so we already have -2 on the outside. What did we say the cubed root of 64 was? 4. What's the cubed root of m to the 6th? M squared. Remember, 6 is not a perfect cube, but as an exponent, it's different. If your exponent divides by your index evenly, then that's all you had to do to take the cubed root. For example, you would do 6 divided by 3 is 2. Okay, that doesn't work for the coefficients. That's just for exponents. So my final answer would be -8m squared. Coolio? Let's do number 2. 256. I doubt that is a perfect fifth, but let's check it out. Decimal, it's not. All right. So I will do my little factor tree. I know it's an even number, so I know it's divisible by 2. 2's prime. 128 is divisible by 2. 64 is 8 times 8. Oops, I'm sorry, y'all can't even see that. And then both of the 8's break down to 4 times 2. And both of the 4's are 2 times 2.
Basically, you do like a factoring
until you get to prime numbers. Yep. So prime numbers are numbers that only have factors of 1 in themselves. So I have 1, 2, 3, 4, 5, 6, 7, 8 2s. And that was it, right? Now that's a lot, so I'm definitely going to check and make sure that 2 raised to the 8th power is 256 to make sure I didn't forget anything. And it is, so I'm good there. So if it's 5th root, I need 5. Groups of 5. You might have more than one group of 5. That's fine. But groups of 5. So 1, 2, 3, 4, 5. And I have 3 left over, so those aren't part of my group, right? I only need groups of 5. So 2 raised to the 5th power. So that's 32 times, multiply what's left together. 2 times 2 is 4, 4 times 2 is 8. 32 times 8 is 256, right? Okay, so that's the 5th root of, instead of 256, I'll substitute 32 times 8. Is k to the 8th a perfect 5th? No, but does it have a perfect 5th factor? Yes, how could I rewrite that? Exactly, k to the 5th times k cubed. That's still k to the 8th, right? I just rewrote it so that it had a perfect 5th factor, just like I did with 256. So in this one, everything under the radical is not a perfect 5th. So I know there's going to be a radical in my answer. So whatever we take the 5th root of goes on the outside. Whatever we can't take the 5th root of stays in the radicand. So what is the 5th root of 32? 2 goes on the outside. Can we take the 5th root of 8? No, because 8's prime factors are 2 times 2 times 2. We have 3 2's, not 5. So 8 has to stay under the radical. What is the 5th root of k to the 5th? Okay, that goes outside. Can we take the 5th root of k cubed? No, we don't have enough, right? So k cubed stays under the radical. And that's your final answer. We good with that? Okay. Let's skip down, look at 7 through 10. Now, we didn't have problems just like this in our notes, but it's multiplying radicals, and we did do multiplication of radicals in our notes, okay? This is just written differently. So remember, you can multiply radicals as long as the index is the same. You can multiply the radicands together. You can multiply what's on the outside of the radicals no matter what. Okay, but to multiply the radicands together, they have to have the same index. So negative 3 square root 10 has an index of 2, right? Both of the radicals in the parentheses also have an index of 2, so we can multiply those together and then see what we can simplify. So we're going to distribute. Negative 3 is a coefficient. You multiply the coefficients together. So the coefficient of this radical is 1. So negative 3 times 1, that's just going to be negative 3 times the square root of what? 20. Then I do negative 3 times negative 5 is positive 15. And the square root of 10 times the square root of 6 is the square root of 60. Now, I cannot add 2 radicals together unless their radicands are exactly the same. Multiply. Only thing you have to have the same is the index. But when you add them together, think about adding like terms. Like you can multiply not like terms together, right? But you can't add and subtract not like terms. So a radical, you'd have to have the same radicand. So right now, we can't multiply these together. But if I can simplify either of these, I have to. And maybe we can add them together after that. I don't know. But we have to simplify anyway. So 20, does it have any perfect square factors?
Yes,
4, right? I can already see right there that's going to be 2 times 2, which is going to be 4. So I'm just going to leave it as 4 times 5. So I'll replace that with 4 times 5. Plus 15 times, let's see, 60 is 2 times 30. 30 is 5 times 6. 6 is 2 times 3. So my prime factors are 2 times 2 times 3 times 5. Do I have any perfect squares in there?
4.
Yes. So I'll replace 60 with 4 times 15. Okay? So, what's the square root of 4? 2 times the negative 3 that's on the outside gives me, so negative 6 square root 5 plus square root of 4 is 2 times the 15 that's already on the outside is 30 times the square root of 15, and 15 is 5 times 3, so I can't break that down. Now can I add these together? No. The radicands still aren't the same. Okay? So you still would have to simplify what's under the radical, even if in the end you still can't add them together. You would still need to simplify what's under the radical. Okay? Cool with that? And you're going to do the same thing with 8, 9, and 10. And all of those are all just square roots, so you can multiply them all together. Just remember, when adding, must have the same radicand. And if you did have the same radicand, you would just say, for instance, you had 2 square root 5 plus 4 square root 5. If you had that, you would only add the coefficients. That would be 6 square root 5. You don't add what's under the radical. Okay? Just a little extra example over to the side. All right, 11, 12, 13, and 14, write each expression in exponential form. Currently, it's in radical form. Okay, exponential form means we're going to rewrite it. There's not going to be a radical, and our exponent will be a fraction. That's what rational means, right? So, this is the square root of 10m quantity cubed. What is the index of this problem? 2. If there's no number there, we know it's an implied 2. So we know to convert it, it would be 10m. And not just the m's not the one raised to the fraction. The whole thing is raised up to the what? 3 over 2. 2 over 3 is not the same, okay? Index is the denominator. The exponent is the numerator. If you just put 10m raised to the 3/2, that's incorrect, because that means only the m is being raised to the 3/2. Well, the 10 and the m are both being raised to the 3/2, so the parentheses are important. So that's all you have to do with all 4 of those. So when I was saying, yeah, there's a lot of problems, but a lot of them are just converting like that, you know. If the index is 2. So like on 13, my index is 3. So that one would be 10n quantity raised to the what? 2/3. The index always goes in the denominator. Coolio? Alright. 15 through 22, write in radical form. That's going to take 2 seconds to do each one. Yeah. Okay, so 15, let me write that in radical form. So what's my index on this one? 2. Do I write 2 if 2's in? No. So that's the square root of 3m raised to the what? 5th power. So I like to write it like this, but the test that I give you, they will have the square root of 3m, and they like the parentheses on the outside. I don't like it that way, but that's the way they write it. They mean the same thing. Okay? Okay. On number 17, it has a negative exponent. All right, so remember, to get rid of that negative exponent, I will drop 10b cubed. If it's in the numerator, I would put it where? In the denominator. And that will change that negative 1/4 to positive 1/4. So what do I put in the numerator? 1. Now, I haven't converted it to a radical yet, have I? No. So that would be 1 over, what's my index? 4, the denominator, right? So that's the 4th root of 10b cubed raised to the first power. So do I need to put raised to the first power? No. If it was the second power or third power or fourth power, then I would do that. But raised to the first power, y'all know we don't need to do that. So we just get rid of that negative exponent by dropping everything to the denominator since it started in the numerator. And that changes the sign of the exponent. If it was in the denominator, if we moved it to the numerator, it would change the sign of the exponent. We cool with those? So 15 through 22, that's all you're doing, just rewriting it in radical form. 23 through 26, simplifying. Okay, so 64 is being raised to the 5/6, and p to the 6 is being raised to the 5/6. So I would simplify that by rewriting it in radical form first and going from there. So in radical form, what would be the index? So the 6th root of 64 p to the 6th quantity raised to the what? 5th power. Now you can either do 64p to the 6th raised to the 5th first, or you can take the 6th root of 64p to the 6th and then raise it to the 5th power. Well, let me see. Is 64 a perfect 6? Let me check that out first. It is. Did you say, how do you figure that out? Put it in your calculator. So if I want to take the 64th root, the 6th root of 64, I'd put 64. And I don't want to raise it to the 6th power, so I don't just push y to the x, because that means raise to the exponent of. But in green above it, see it's x, your index is x, so that means you can put in whatever index you want. But to get to the green, you have to push the second button first. So I'd hit second, that button, and then put my index in, which is 6 equals. If I don't get a decimal, then it's a perfect 6. 2 is the 6th root of 64. And is p to the 6th a perfect 6? Yeah. So probably for me, because 64 raised to the 5th power, it's going to be a big number. I would do, all right, the 6th root of 64 is 2. What's the 6th root of 6? P. But you still have to raise it to the 5th power. We haven't done that yet. It's 2 to the 5th power and p to the 5th power. So 2 raised to the 5th power is 32. And p raised to the 5th power is p to the 5th. Or you could have, let me redo it again the other way. I could have raised everything to the 5th power first. So 64 raised up to the 5th power. Whoa, wowza. See, maybe I wouldn't want to do that. But, and then I could take the 6th root of that is 32. Same thing I got over here. I just didn't write all that down. P to the 6th raised to the 5th power would be p to the 30th, because remember, exponent rule, power to a power you multiply. And so p to the 30th, the 6th root of that would be p to the 5th. But the way I did it just gave me smaller numbers. It doesn't matter which one you do first, but you just have to do both. All right. So like 25, if I turn that into a radical, when you raise something to the 1/2, doesn't that mean you take the square root of it? Right? The index is 2. You raise it to the 1st power. That's just square root. So that's the square root of 64, x to the 4th. What's the square root of 64? What's the square root of x to the 4th? All right. Let's look at 27 through 36. Simplify. Your answer should contain only positive exponents. So 27. I can multiply these together. So coefficients times coefficients. 2 times 4 is 8. What's x cubed times x? X to the 4th. What's y to the 4th times y cubed? Y to the 7th. That's all I can do there. Look at 27. So a times 3ab cubed. Well, isn't that 3, what's a times a? A squared and b to the negative third. Can I have a negative exponent? No. Does 3 have a negative exponent? No. Does a squared have a negative exponent? No. Only the b does. So the 3 and the a squared stay in the numerator. The b is the only piece to drop to the denominator, and when we do, it will change the sign of the exponent. Okay? So 31, I would probably simplify each one of those separately first and then multiply them together. Okay, so isn't 2 being raised to the 4th power? And y squared is being raised to the 4th power. So that's a power to a power. Remember, you keep the base and do what to the exponents? Multiply. Multiply. Power to a power. Keep the base, multiply the exponents. Times y is being raised to the 3rd power. And x would be raised to the 9th power. Can I simplify that further? Yeah. Well, first of all, 2 raised to the 4th power is 16. So that's 16 y to the 8th times y cubed x to the 9th. Now I'm going to multiply them together. My coefficient 16 times 1 is 16. What's y to the 8th times y cubed? Y, close. Y to the 11th. X to the 9th, my first term doesn't have an x, so I just bring down x to the 9th. Okay? Look at 33. I would, before dealing with the negative exponents, I would get rid of this exponent on the outside. I'd multiply everything to a power, and then deal with it from there. All right, there's another way you can do it. That's what I would do. So x to the 4th raised to the negative 1 would be x to the negative 4 times x to the positive 4th times y to the negative 2. Now, okay, so what I could do is I could go ahead and drop this x to the 4th down to the denominator. Or when I multiply like bases, don't I keep the base and add the exponents? Right? So I could do that as well. Well, what's negative 4 plus 4?
0.
So that would be x to the 0, which is 1, right? So that turns into a 1. And what do I do with y to the negative 2? Drop it down. So I didn't need to write that little multiplication symbol. So my answer on that would just be 1 squared. Now, if I would have dropped this down to the denominator, say I said, okay, well, this x to the 4th is going to go to the denominator. This x to the 4th will stay in the numerator. And y to the negative 2 will go to the denominator. Well, I've got x's in the top and x's in the bottom, right? What's x to the 4th divided by x to the 4th? 1. So they end up canceling. Or you could say x to the 4 minus 4 is x to the 0. You get 1 either way. So either way you do that, you still end up with the same answer. Let's look at 35. Okay. I would probably get rid of this exponent first. So each part in this term I've got to raise up to negative 4. So that's going to be v to the negative 4 times 2 to the negative 4, v to the negative 4, u to the negative 8. And the denominator, I don't have any power to a power, so right now I'm just going to rewrite it. Okay. Let's see, what could we do? We could do a couple things here. I'm going to go ahead and just, wherever I see a negative exponent, I'm going to move it, okay? And remember, all of this stuff is being multiplied together. So if you move something from the denominator to the numerator, you just multiply it by whatever's there, or vice versa. So v to the negative 4th will go to the denominator. So it's v to the fourth. I'm going to mark everything out as I go as well. 2 to the negative fourth, that will go to the denominator. Bless you. V to the negative fourth will go to the denominator. U to the negative 8 will go to the denominator. The 2 that was already in the denominator is going to stay in the denominator. The v to the negative third in the denominator will move to the numerator. I've got another 2 in the denominator. And that u cubed will stay in the denominator. So this looks crazy, but just take it one step at a time. All right, so I have v cubed in the numerator. And the denominator I have a lot of like terms, right? So first let me figure out my coefficients. I have 2 to the fourth times 2 times 2. Well, what is 2 raised to the fourth power? 16. 16 times 2 is 32, and 32 times 2 is 64. So all of this multiplied together will give me a coefficient of 64, right? Y'all with me? Yeah. Okay. Yeah. What's v to the fourth times v to the fourth? 8. V to the 8th. What's u to the 8th times u cubed? U to the 11th. Is there anything else I can do to simplify? The 2 v's. Right, I got v cubed in the numerator, v to the 8th in the denominator. Remember the rule says keep the base and subtract, so that would be v to the 3 minus 8 is v to the what? Negative 5. So your u's will end up in the denominator, or this is how I do it. I say, okay, I've got 3 v's in the top, 8 in the bottom. Where do I have more v's? In the bottom, so I know they're going to end up in the bottom. How many more do I have in the bottom than the top? 5. So that's what I do in my head. Okay, but technically you're keeping the base, subtracting the exponents. 3 minus 8 is negative 5. Means it's going to go in the bottom. So what's left for the top? 1. Just a 1 over 64 v to the 5th u to the 11th. Okay? Remember, next set, 37, 38, 39, 40. When you're solving radical equations, you have to get the radical isolated before you can get rid of the radical, okay? So look at 37. Is 6 being added to the radical or multiplied? So how will we get rid of that? Divide by 6. So I have the square root of 3x plus 24 equals 3. Now, I want to get to the x, but it's under a radical. So what is the inverse of square rooting something? Squaring. And if I do it to one side, I have to do it to the other. So the square root of 3x plus 24, quantity squared, is 3x plus 24. 3 squared is 9. Then I'll subtract 24 from both sides. So we have 3x equals negative 15. Divide both sides by 3 and x equals negative 5. Don't forget you have to check for extraneous solutions on these. So I can just do this in my head. 3 times negative 5 is negative 15. And negative 15 plus 24 is 9. The square root of 9 is 3 times 6 is 18. 18 equals 18. Good to go, right? So remember to check for extraneous solutions. So on number 39, what would you start off doing first? I'm not going to do it. Just what would you do first? Subtract 7. And then take the square root of both sides and go from there, right? Okay. And I can tell you the answer to 38 is 26. Obviously, you have to show me your work. The answer to 39 is negative 4. The answer to 40 is 1. 41 and 42. The answer to 41 is n equals 5. The answer to 42 is a equals 9. All right, 43 through 48, solve each equation. So these don't have radicals, but they have rational exponents. So that's pretty much the same thing as having a radical. If you have a rational exponent, you have to get rid of anything. You have to isolate that first, okay? It's already isolated, sweet. So 4p minus 3 raised to the 3/2. Do I have anything outside the parentheses that I need to get rid of? There's nothing outside the parentheses on the right side, correct? All right, so remember, I could convert that to a radical, or I could raise both sides to the reciprocal of the exponent. Remember that? Which would be what? 2/3. So when I raise 729 to the 2/3, I would convert that to a radical. So that would be the what root? Cubed root of 729 squared equals, when I multiply 3/2 times 2/3, a number by its reciprocal, you get 1, right? So 4p minus 3 raised to the first power is just 4p minus 3. So I'm hoping 729 is a perfect cube. Let's check it out. 729 cubed root. Boom. So if I take the cubed root first, cube root of 729 is 9, but then I'm going to have to square it. Or I could have squared it first. I could have done 729 squared is that number, and then take the cubed root of that, and I would still get 81, which is what I'm going to get here, right? Equals 4p minus 3. So 81 equals 4p minus 3. And then we just have a basic two-step equation. Add 3 to both sides. Divide both sides by 4. And p equals 21. The answer to 44 is 81. The answer to 45 is negative 23.
We won't have a lot of questions like this.
No, we won't have this many questions. I wanted to put plenty on there so I had more that I could go over with you. 46, you have two answers. You have r is equal to positive and negative 125. And I put a lot on there because a lot of them were just converting. I'll do 47 with you. So on this one, what do you think you do first? Subtract 10 from both sides. So you have 125 equals b to the 3/2. Then what do you think you do? Multiply both sides, or not multiply, raise both sides to the reciprocal. So raise both sides to the 2/3. So 125 raised to the 2/3, I would convert that to a radical. So that would be the what root? Cubed root of 125 squared equals b raised to the 3/2 raised to the 2/3 is b to the first, which is b. So isn't 125 a perfect cube? We get 5, right? So that would be 5, and then we have to square it. So b equals 25. Or you could have done 125 squared and then taken the cube root of that and gotten the same thing. The answer to 48, k equals 46. Do you see any in that section that look confusing, that don't look like the rest of them? They all pretty much look like an example I did, right? And then 49 is one of those real world problems where there's a part A and a part B. And part A, I think it just wants you to isolate the y. And then part B, you have to just answer a question by substituting in a number, like we did on topic 4, I think it was. Okay, so I didn't give you the questions, so like when you have to convert, because that's all you have to do, there's no work to be shown there. And I will have the answers to these up here, but I'm afraid if I give them to you, you just write them down, and some people just won't show me work and say, oh, I did it in my head, that's what I got. So after you work on them, you can come up and check them. But make sure you show work for everything. Only thing you don't have to show work for is when you convert them, because there's no work to do. You're just converting it to the other form. So look through the rest of them. Are there any of those that look weird? That I didn't do one similar? We good? Okay. Then I will post this video on Edmodo before I leave today. So if you need to go back over, if you want to hear it again without having to take the notes and just listen, it'll be on there. Okay? And then our tests for this class, first period, is Thursday.
And this our last test for the 9 weeks?
Yes.